human body, such a complex thing, but what is it made of? Well, let us tell you. It's made of 3 different types of muscles: skeletal muscle, cardiac muscles, and smooth muscles. But today we're going to be focusing on the inner workings of a skeletal muscle and how it contracts.
In this model of the skeletal muscle, you can see it is made of fascicles that contain multinucleated myofibers, which is where the mitochondria are, which turn into myofibril. Then, as action potential travels down the axon towards the neuromuscular junction, it opens up calcium channels, letting the calcium in, which then pushes the vesicles out, letting acetylcholine out into the synaptic cleft, which then opens up the potassium and sodium ions, letting potassium out and sodium in, as the acetylcholinesterase waits down at the bottom to sweep the rest of acetylcholine out.
The sarcoplasmic comes down into the T tubules, which is bordered by the terminal cistern within the sarcoplasmic reticulum. This is where the calcium is sequestered and is released during muscle contraction as the action potential travels through the muscles.
Myofibrils contain contractile units called sarcomeres. Sarcomeres run adjacent to one another down the length of the myofibril. Each sarcomere consists of alternating thick and thin protein filaments, giving skeletal muscle its striated appearance. The muscle contracts when these filaments slide past each other. The thick filaments are myosin, which are anchored at the center of the sarcomere. The length of the myosin is the A band. The thin filaments are composed of the protein actin, which are anchored to the Z line on the outer edge of the sarcomere. Because the actin is anchored to the Z line, the sarcomere shortens from both sides along the myosin filaments. The area where the myosin filaments don't reach is the H band. The area where the actin filaments don't reach is the I band.
Calcium floods over the thin filaments and binds to troponin, pulling tropomyosin off the active sites on the actin. High-energy myosin heads leap to bind on the exposed active sites on the thin filaments, forming a cross bridge. The myosin head pivots to the low-energy state, releasing ADP and moving the thin filaments over the thick filaments, the power stroke.
ATP then binds to the myosin head, causing the head to break free from the active site on the actin. The myosin head becomes energized as ATP is then converted to ADP.